Now we also need to recognize the different IV graphs for different conductors or components, electrical components. The first one is actually what we call as an ohmic conductor. So ohmic conductor, you can usually use a resistor. You know the resistor that we usually use this resistor, you can assume to be an ohmic conductor. And the IV graph for an ohmic conductor will be a straight line through the origin. Why? Because it obeys Ohm's law. So if you look at Ohm's law, so it says the current flowing in your conductor here is proportional to the PD applied across it, provided that the physical conditions such as temperature, stress, etc. are constant. So when you say directly proportional, in this case it's actually directly proportional, not just proportional. So it will be a straight line through the origin. So what it means is if you were to calculate the resistance, remember earlier on I was telling you, you draw a line from the origin to any point. So what would that mean? The resistance will be constant. So no matter what voltage we use, the resistance will be constant. Now naturally, the bigger the voltage across the resistor, the higher its temperature. It will be hotter because there will be more energy loss in your resistor. Remember, PD is energy loss as heat per unit charge. So in this case, your PD higher means it will be hotter. But we will assume for the sake of the graph that temperature is constant. Alright? So whatever the voltage, you will have the same resistance. Now what does it mean by the negative side? Since you have positive and negative side. So the positive side means you are connecting, let's say in this direction, the current. Negative means you reverse the polarity of the cell. So can you see the current is traveling in the opposite direction? So here it is flowing anti-clockwise, here it is flowing clockwise. So even if I reverse the polarity of the cell, which is indicated by the negative voltage here, the current will travel in the opposite direction, which is the negative current. Understand that? Okay? Now, when you consider a filament lamp next, a filament lamp is the lamp that we use in the lab, which actually consists of a high resistance filament in the middle. So when the current flows through, it actually becomes very hot. And because it is very hot, it glows. That's how it produces light. And then what will happen is, for this type of filament lamp, the graph of IV is actually curving. So what does it mean? So what does it tell you about the resistance? So once again, we can put the gradient as equals to I divided by V, which is 1 over R, right now. So in this case here, the gradient of the line drawn from the origin, so if you draw a line from the origin, is getting steeper or less steep? Less steep. So if it's getting smaller, that means the resistance must be getting bigger. So for a filament lamp, when the PD increases, the resistance increases. Why? Okay, so the understanding is very simple. When the PD increases, we know that it will glow brighter. And why it glows brighter? Because it's hotter. And because it is hot, and because it's hotter, there will be higher resistance. Okay, now, remember I was telling you about conductors where they already have free or mobile charge carriers, which is our free electrons. Now, when our filament lamp, which is actually the filament inside there, which is a metal, when it becomes hotter, you won't get extra electrons. The number of free electrons is still the same. But what will happen is the atoms in your filament will start to vibrate faster because when temperature goes up, KE goes up. So when the atoms vibrate faster, the electrons find it harder to pass through. Understand? Now, imagine you're trying to walk between two lines of people, but the people keep vibrating, so it's harder for you to walk through them because they'll keep knocking you. Understand? Now? So you will actually slow down. So that is why when temperature goes up for a conductor, the resistance goes up because you don't get extra electrons, but you slow down due to collisions. Okay? And once again, you see a negative part here. So it basically means that I can reverse the polarity of my cell and the current would still flow, no problems, but just in the opposite direction. Okay? And lastly, for a semiconductor diode, you will have many different shapes. So I cannot save I cannot tell you all semiconductor diodes will look like this. There are many variations of semiconductor diodes. Why? Because you have many different types of semiconductors. So, but for sure, you will see a common characteristic. Firstly, in the forward direction, we call it forward bias. Forward bias means I will connect the cell across the diode this way. So this means that current can actually flow through the diode. This is called forward bias. So when it's forward biased, it will allow current to flow. So you will see current here. But when it's reverse biased, that means for this side, or rather from this side and also this side both you will connect the voltage opposite direction, but the diode is the same. Can current flow? So no current will flow. So you will notice that initially, when you increase the voltage, there's no current, or sometimes they will show you a tiny current very tiny current But if you keep increasing the voltage, this diode cannot stop the current anymore, so this diode will break down. And when it breaks down, the whole diode will conduct electricity. So suddenly, there will be an infinite current flowing. Do you understand? So that's called the breakdown voltage. So diodes will be able to stop current from flowing in the opposite direction, but up to a certain maximum voltage. After that, it breaks down. Okay, it just gives up. Now, other variations of the diode for the forward bias part, sometimes you will see it will be a straight line first, then curve. Alright, or sometimes it will be curving all the way. So there are many different variations, or be straight line, then it curve. So there may be many variations. So the best way is to compare the forward direction and the reverse directions. Alright, that's the only way to see the diode. Okay. Now next we will just learn a bit about the thermistor. Now what is a thermistor? A thermistor is a short form for thermal resistor. Alright, so how does a thermistor behave, right? You will notice that when the temperature of a thermistor increases, the resistance will actually decrease. So it will have an opposite behavior as to a conductor. Because just now when we talk about filament lamp, when the temperature increases, remember the resistance increases. But for a thermistor, when the temperature increases, the resistance actually decreases. Now why? Because your thermistor is a semiconductor. It is not a conductor. And how semiconductors conduct electricity is very different. You see, semiconductors are similar to insulators in the sense that under normal conditions, they do not have any free electrons. Okay? But for a semiconductor, if you give the electron sufficient energy, it will be able to jump out and become free electrons to conduct electricity. Whereas an insulator, the electrons need too much energy in order to jump out, so it's not practical, so you would not conduct electricity. But for semiconductor, the energy required by the electrons to come out is actually not too big, so you just give it a bit of energy, it will come out. Example for a thermistor, you give it actually heat. So you give the electrons heat energy, it will jump out and become free electrons, and therefore it will start to conduct electricity. So when temperature increases, more free electrons, so the resistance will drop. Understand that? You compare it to a metal or a conductor like the filament lamp. When you increase the temperature, you still have the same number of free electrons. That's why it's not the same. You understand that? Okay, this one will get higher temperature, more free electrons. That's the difference. Okay, but now people also ask me, what about thermal vibrations? Wouldn't the atoms vibrate faster, so it finds it harder to pass through? I say yes. So there are two things happening. You got more electrons coming out, at the same time the atoms vibrate faster, so there's more collision. But overall, the effect of having more electrons is more significant. So therefore, the resistance drops. So when you draw the IV graph for a thermistor, it will be using this same concept I taught you. So you draw a line from the origin, so the gradient of that line of IV graph would give you 1 over R. So since we know the resistance would drop, the gradient has to increase. That's why you notice that the graph here curves upwards. Because if I draw a line from the origin, it must get steeper. Do you understand? Now, for a thermistor, it also has no polarity, so which means to say even if I reverse the connection to the cell, it will still be able to conduct electricity, no worries. But the only one that won't be able to conduct is diode actually. All other components that we learned doesn't matter the polarity. Okay? Now remember, when the voltage increases, the temperature of the thermistor will increase, because higher voltage means higher PD. That means more energy loss. That's why I would relate the increase in PD to an increase in temperature, which is a decrease in the resistance. So the symbol for a thermistor is actually just a resistor with a Nike symbol. Understand? To show you that there's a thermistor, not just a normal resistor.